Hello and welcome. This video is for Algebra 1, and we're going to be reviewing how to evaluate expressions with integers. Okay, so in algebra, when we have something called an expression, that means it does not have an equal sign. So for example, if we had negative 5n plus 3 equals 2, we would call that an equation because there is an equal sign. Instead, today we're going to be working with expressions which do not have an equal sign. So if I was to take this part away, this would be an expression. It's a mathematical way of representing a quantity, but we just don't know what n is equal to, and we don't have an equal sign or anything on the other side that we can use to solve for n. So we cannot evaluate expressions, and I'm going to take this part down just to demonstrate this. So our expression will be just negative 5n. We cannot evaluate or figure out what this is equal to unless we know what n is equal to. So if we're being asked to evaluate an expression, someone has to tell us what n is equal to. In this case, we'll make it equal to negative 1. So right now, what this means is that negative 5n is the same as negative 5 times n. You could even put a little multiplication dot in between. So this is the same as negative 5 times n. To evaluate the expression, what we want to do is replace the n with the value of n we were given. So instead of n, I'm going to take that out. I'm going to replace it with negative 1 because that's the value we were given for n. So now I can go ahead and do the mathematical calculation. Negative 5 times negative 1 should be positive 5. So when n is equal to negative 1, this expression is equal to positive 5. Now, what if I took the same expression and gave it a different value of n? So I'm going to do that. Instead of negative 1, I'm going to make the value 3. So now I can evaluate the expression negative 5n when n is equal to 3. So negative 5 is still times n, right in between there. So I'm going to do negative 5 times n, but this time I'm going to replace the n with the 3. So I'm going to take that out and substitute in the 3. Well, negative 5 times 3 is negative 15. So this expression is equal to negative 15 when n is equal to 3. Okay, so we're going to do a few practice problems with this concept. We're going to evaluate this expression when w is equal to 19. So our expression is right here. It's negative w. Well, in algebra, when we have a negative in front of a variable, that's the same as saying negative 1 times w. So I'm going to write that out like that because that's going to make it easier for me to evaluate. Now what I can do is I can just come and replace the w with 19. So I'm going to go ahead and cross this off or erase it and replace it with 19. Well, negative 1 times 19 is negative 19. So that would be your answer to this problem. We just evaluated the expression negative w when w is equal to 19. If w is equal to something else, we would have gotten a different answer with the same expression. Okay, here's our next one. We're going to evaluate the expression when s is equal to 2. The expression is 10s minus 12. So I'm going to go ahead and write out what's happening here. 10 times s minus 12. So I'm going to replace the s with 2. That's a value for s we were given. So I'm going to replace that s with a 2. Now, when you have an expression that has multiple operations, not just one operation, once you have your numbers substituted in for your variables, you're going to still follow order of operations, or PEMDAS or GEMDAS, however you learned the order of operations. So I'm going to write that over here just because we have a multiple operational expression to evaluate. So here's PEMDAS. That means parentheses, exponents, multiplication and division from left to right, and addition, subtraction from left to right. When I look at our expression, I see we have multiplication and we have subtraction. So according to PEMDAS, multiplication would come first. So I'm going to go ahead and delete those, but I'm going to do this first. So 10 times 2 would be 20. So I'm going to go ahead and do that, and I still have this operation to do. Now all that I have left is subtraction, and 20 minus 12 is equal to 8. So the evaluation of this expression when s is equal to 2 is 8. Now that same expression when s is equal to something different would give us a different answer. Okay, here's our next one. Evaluate the expression when f is equal to 67 and g is equal to negative 58. Okay, so this is a little bit more of a challenge one because now we're dealing with absolute values. And if you don't remember what absolute value is, or those big long bars on the either side of the expression, that means distance from zero. So what they want to know is a part of the final answer. They're talking about the distance of zero from zero that f plus g would be. So let's kind of go ahead and put an absolute value here, f plus g and another absolute value. So we can go ahead and replace f with 67. So I'm going to go ahead and erase that and put 67. And then I can replace g with negative 58. So I'm going to erase g and put negative 58. Okay, so that means before we get into the absolute value part, we need to calculate what's inside the absolute value bars. So we need to do 67 plus negative 58. So we'll go ahead and calculate that. And when we do, we should end up with 9 inside these bars. So now we can talk about the absolute value parts. They want to know the distance that 9 is from 0. Well, 9 is 9 units away from 0. So the absolute value is 9. So that's our final answer. When we evaluated this expression, we got 9. Now, if the values of f and g were different, again, we would have a different answer, even though it's the same expression. Okay, here is our next one. Evaluate the expression when k equals 8, m equals 6, and n equals negative 6. Okay, so let's kind of write out this expression we are given, which is km minus n. That's k times m minus n. So I can replace k with 8. So I'm going to erase k and put 8. I can replace m with 6. So I'm going to delete the m and put a 6. And then I can replace n with negative 6. So I'm going to delete n and write in negative 6. Okay, so again, we're going to follow PEMDAS because we have multiple operations here. That would be parentheses, exponents, multiplication, division from left to right, and addition, subtraction from left to right. And I like to put these little symbols here to remind me what those are. Okay, so looking at our expression now, we have multiplication and we have subtraction. So according to PEMDAS, we would need to do the multiplication first. So I'm going to come over here and multiply these two numbers, which would give me 48. So I have 48 minus negative 6. Now all I have left is the subtraction. So when I'm minusing a negative, that becomes a positive. So I'm going to change that to a plus. And then when I add 48 plus 6, I end up with 54. So the final evaluation of this expression is 54 with these given values for our variables. Okay, here is our last practice problem for today's video. We're going to evaluate the expression when t is equal to negative 4 and u is equal to 5. So I'm going to go ahead and take our expression, which is t times u squared minus t, and just kind of rewrite that out. That's t times u to the second power minus t. So I'm going to go ahead and replace t with negative 4. So that means I replace this with negative 4, and I have to replace this t with negative 4. Okay, now I'm going to go ahead and replace u with 5. So I'm going to erase u and replace it with 5. Okay, so we definitely have multiple operations here. So I'm going to go ahead and write out PEMDAS so I know what I need to do first. Parentheses, exponents, left to right, left to right. Okay, so even though in this expression we do have parentheses, those parentheses are just kind of calling out to us that this is a negative number. So there's not actually an operation to do in there. So we're going to skip that part. We don't need to do anything there. The exponent is the one that we have next, which is right here. And that is 5 to the second power. Well, 5 to the second power is 25. So I'm going to go ahead and put that in here. So we have negative 4 times 25 minus -4 is what we have left. Okay, now according to PEMDAS, since we did the exponents, it's a multiplication or division. Well, I see multiplication over here on the left, so I'm going to do that next. -4 times 25 is -100. So I have -100 minus -4. Okay, my next operation, or my only operation left, is subtraction. So when you're subtracting a negative, you turn that to a giant plus sign. So what we're really doing is -11 plus 4. Or sorry, not -11. Oh my goodness, -100 plus 4, which should give us -96. So our final answer here would be -96 when this expression has these values for its variables. Again, if the values of the variables were different, our answer would be different even if we use the same expression. Well, thank you so much for joining me today. I hope to see you again soon.